Hi everyone, this is just a quick video to show a little job that we did recently. This job involved certifying a bracket that is used to hold the crossarms onto a pole without any king bolt through the actual pole. This client has these rail poles that are welded toe to head, and basically they can't blowtorch through them anymore to put a king bolt through, and you can't drill them, they're too brittle. So they came up with this idea with a tapered flange beam that had a notch out of it to fit in around the foot of the rail, and they just wanted to certify it to make sure it was okay. As it turns out, it was probably a little underdone if you're going to certify it to the current standards, particularly in wind regions C and D. As you can see, this was a bit of a giveaway that it was a little bit underdone, just because they were bending the TFCs just when they were applying the tension on the bolts to clamp it to the pole to give it the friction needed. So the criteria for this was we had to handle cyclonic wind speeds, it had to be light enough for installation, so we couldn't have anything too bulky, and it had to take up to a 45-degree deviation on both the stays and the conductors, and we had to handle 120 metre spans, pretty heavy conductors, and it had to be able to, it had to be able to be used in intermediate, strain and termination arrangements. So immediately looking at the complexity and size of the actual structure, we knew a finite element model would be the best solution in this particular case. After comparing a few common software options, we decided to go with S-frame. If you're doing portal frames all the time or simple poles and stuff like that, it's not that much different. But for this sort of stuff where you've got to put all your points in for all the extremities of your plates and mesh your plates and make sure everything ties together properly, and then we also use slave nodes to tie some of these things together at the bolt points, and tension only members for with pre-stress on them for the cross bolts, things like that. It's much quicker, just the way that they model things, the way you do your geometry entry with your nodes and things like that. It's just a lot quicker than the likes of space gas and things like that, which are more suited for the portal frame stuff. They can do this, but S-frame is just a lot quicker at that sort of thing. We then used 3D shop detailing software. This gives you a bit of an idea of that rail pole and the complexities that were required to be taken into consideration here. This is without that stay plate on the front of it, or termination plate on the front of it. This gives you an idea of the model that we use for the shop detail drawings. So we used the 3D shop detail drawing to make sure it all fit together, it was all going to work, and then we actually produced the fabrication drawings out of this particular model. In the end, the test piece all fit together really nicely. The client was super happy with how it all went together, and they're going to go and manufacture these for use on their network.